So which of the following is an incorrect statement? All right, so the question stem doesn't tell us anything. We're looking for an incorrect statement. I guess we want to know that. Incorrect. In histograms, relative areas correspond to frequencies. All right, so what is a histogram? Well, a histogram has the general form. It looks like this, where this is frequency over here, which I'm going to call F, and this is some other variable which we don't want to get into right now. So relative areas correspond to relative frequencies. All right, so this doesn't necessarily tell us, well, in this case it does tell us the frequency, right? And boom, 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 boom. But sometimes you can have a histogram. It's a pretty ugly dotted line, but sometimes you can have a histogram where it says actually relative frequency, in which case it doesn't tell you the actual frequency, it just tells you the relationship with respect to each other. But it doesn't really even matter here, because we know that relative areas, that is this area here, an area is equal to base times height, right? Where this width, which is equal to width times height, where this width is just the base of that rectangle. So it turns out that this is a correct statement. It is correct. And so I'm going to cross this off. Bam. Okay? In histograms, frequencies can be determined by relative heights. Okay. Well, not always. Frequencies can't be determined by relative heights because it turns out that if this is a relative frequency over here and not an actual frequency, it turns out that we don't know, right? So this could be, if this is 20, this could be 40, but this also might be 2, in which case this would be 4, right? So the relative frequencies are the same, but we don't know the actual frequencies necessarily, okay? So let's hold off on that one. It turns out that's the answer. But let's see why this is actually incorrect. Okay, let's see why let's see why C is correct. Systematic histograms may have multiple peaks. All right, so if you think about a systematic histogram, you might think, all right, well, here's a systematic histogram. I'm sorry, symmetric, pardon me. There's a symmetric histogram, and it only has one peak. But this is also a symmetric histogram, right? And so they may have multiple peaks, and so, of course, this is correct. I don't think anybody in our class thought it was C. I'm going through each of them just in case. All right. 2 students working with the same set of data may come up with histograms that look different. I think we did this together in class yesterday. It turns out if we had a set of data that looked like this, let's do a stem plot. 5, 1, 4, 6, 2, 3, 7. Just making numbers up. 3, 4, 8. It looks like I like the number 4, huh? One student might have a histogram that goes from 0 to 10 and 10 to 20, in which case they would have, oh, it looks like I've got more than that if I do that, right? 30 and 40. One person's histogram might look like this. 0 to 10's got 2 values. Let's make, oh my goodness, they all have 2. Oops, better put another one here. 3, 4, and 8. Okay, so that's got 2. From 10 to 20 has 3, so it looks like it's going to be about there. Oh, my art's really bad today. And then from 20 to 30 is going to have 2 again. Bam. And then from 30 to 40 is going to have 4, right? Look like that. Okay, that's what one student might do, but another student, this seems like a waste of your time. If you already get this, bear with me, because I think it's good to chew on these things. Another student might divide this up from 0 to 20 and 20 to 40, right? In which case, 0 to 20 is going to have 5, and 20 to 40 is going to have 6, right? So these are 2 different histograms by 2 different students. So we know that D is not correct. Okay? And then I'm running out of space here. Displaying outliers may be more problematic when using histograms than when using stem plots? Well, it turns out that a stem plot, you can't skip a stem. So if you have an outlier, let's make up some more data here, okay? 0, 1, 2, 3, 4. And let's say we have 2, 3, 6, 4, 8, 7, 4, 2, I think I like 4. Let's put some more 4s in there. 7, 9, and 4. And then an outlier might be 41. Well, if you have a stem plot that looks like that, you really can't skip these. You have to put them there anyway, because that's what our definition of a stem plot requires. So it turns out that and a histogram probably have, I can't think of an example in which case displaying outliers may be more problematic. It turns out, I'm sorry, that's why E was attractive to me. However, it turns out, talking to one of the students after class yesterday, he thought of an example where it could be more problematic, and that would be maybe where you divided this up into different groups. Sort of, let me do another stem plot, okay? 0, 1, 2, 3, 4. From 0 to 2, from 2 to 4, okay. So let's say one stem, I'm mixing my stem and my histogram, aren't I? Let's go 2, 3, 4, 5, 4, 5, 1, 1, 3, 2, making numbers up, right? And 1, 2. You could do, I'm just going to do the histogram as an inset here. I know this is ugly. From 0 to 10, or rather 0 to 20. And from 20 to 40, this looks like 1, 2, 3, 4, 10 values, right? And this only has 2 values up over here. So this doesn't look like an outlier. Actually, it should be going here, right? It doesn't look like an outlier, but it is. Okay, so it turns out they, in fact, may be. Yes, they may be, although that is really subtle. And I got to tell you, I don't really care for this problem. That is really subtle. We're going to say, yes, it may be, therefore that's correct. Okay, and it turns out B is the only one that is incorrect. So I hope that's helpful. A little cumbersome, but I saw it as an opportunity for us to review stem plots and histograms a little more thoroughly, and my hope is that that will be useful to you.